Hey everybody, in this video we're going to see the concept of half-life in play in a real fluid system. I have with me two graduated cylinders connected by a small piece of plastic tubing. If we fill up one graduated cylinder, water will flow through the tubing into the other. However, much like the example of the draining pipe from last DL, the speed at which water transfers from one cylinder to the other will depend on how much water is in the cylinders. Specifically, it'll depend in the difference of height in the water in the two cylinders. As the height of the water in the cylinders gets closer together, the speed at which the water transfers will decrease. Eventually, it will come to a stop when the heights are the same. I'm going to set up the video so that you can read the numbers on the graduated cylinder in order to take data for yourself. We want to be able to graph the dependence on time of the height in one of these cylinders. To make this easy, I'm going to start with 100 milliliters in one cylinder and no water in the other. There's actually two videos for this activity. The difference between them will be the resistance in this piece of tubing. I'm going to adjust this clamp to change the resistance for the two cases. Half of you are going to do one of them, and the other half of you will do the other. You're going to be able to use this data to measure the half-life of this particular fluid system. Because we're starting with 100 milliliters in one pipe and 0 milliliters in the other, knowing the amount of water in a single pipe will always tell us the amount of water in both pipes. In order to allow you to take data, I'm going to zoom in on the pipe that's starting out full so that you're able to take the data yourself. Here's the full graduated cylinder. You can see the volume markings going down here on the right-hand side. They're in milliliters, so this graduated cylinder is currently filled to 100 milliliters. I'm now going to allow water to flow from this graduated cylinder into the other. Your job is to take data in order to be able to graph how the amount of water in this graduated cylinder changes with time. You may need to pause the video in order to do this. Ready, set, go. As we expected, the speed at which the water level changes goes down as the height of the water itself goes down. This is the classic example of exponential decay.